Hey everyone, today we're going to talk about surface area of a cylinder because I find this one to be a little bit tricky for students to get. I mean, it's just kind of unusual because our base shape here is a circle. And so let's go back to like the net figures. Right now we're finding surface area by doing net figures. Then that means taking apart our 3D shape and laying it flat and finding the area of all the individual pieces. So let's go back to the net figure of a cylinder. So notice when it's all together, look at that. That's our cylinder. When we start to cut it like a can opener, see how we like open it up here, and then you slice like right up the label of your soup can and you spread it out and it looks like that. So now it's flat. So what are those three shapes? Well, I have two circles that should be exactly the same. And then I have a rectangle. So let's go back and take a look at what that looks like on our page here. So check that out. Now that's at a bit of an angle, so I'm going to rotate it just a little bit. So I'm going to take a circle here, and I'm going to take this rectangle here. Oh, my drawing looks terrible compared to those nice drawings, right? Don't worry, we're not meant to be artists here. We just need to get an idea of what we're looking at. So each of these circles should be the same. And let's recall the area of a circle is pi r squared. So let's look back at our original shape. This circle has a radius of 4. So I'm just going to put that in here and label it so that I can see that the radius is 4. I'm going to do it for this one too. Now, let's take a look at our label of our soup can. We have two dimensions for that. Oh, look at that terrible line there. I can't draw today. So this right here is the same as this piece right here, which when it was standing up is this right here. So that should be 8 centimeters. But the big question, this is the kicker, is what is the length of this piece right here? What is that? So that corresponds, let's try and draw that here. That corresponds with this piece here, which, how do we get that? Let's go back and look. Where does that come from? That roundness, that opens up. So it used to be a circle, now it's opening up flat like this. So what that connects to is that connects to the circumference of the circle, or the outside space of this, the fence of it. So if you remember, circumference of a circle is 2 pi r. So that is the length of the top of like that soup can when you open it up. So let's finish off the problem here. So if this is 2 pi times r, remembering that our radius was 4, then that's going to be 2 times 3.14 times our radius, which is 4. So let's put that into the calculator. I put mine way too far away from me, so I'm going to do 2 times 3.14 times 4, and we're going to get that this part, I'm going to label it down here since I'm running out of room. So 25.12 or 25 and 1200ths, and that's in centimeters. So that now is the base here, and our 8 centimeters are the height. So let me show you what I'm going to do. I'm going to put circle plus rectangle plus circle. Okay, so a circle formula for area is pi r squared. We want to add that to the area of our rectangle, which is base times height or length times width, plus another pi r squared. Well, guess what? These two circles are the same. So do you think I can rewrite it like this? Two of those pi r squareds plus a base times a height? I think so. I think we got that. So we're going to do 2 pi times our radius, which we already said was 4, quantity squared, plus our base, which we said here was 25.12, times the height of that, which is 8. So I do one thing at a time. So remember, order of operations says I got to square that 4 first. I'm going to get that 16. I'll multiply it by 3.14, and I'll multiply it by 2. So I'll just rewrite this here so you can see it here. So I'm replacing pi with 3.14, which is what most of the directions tell you to do. And then I did 4 squared, which is 16. So put that all together, you should get 100.48. Plus, then I'll do the 25.12 times 8. and that gives us, that was 200.96. I'm just going to copy that down here, trying to keep track of my work so that when I'm getting partial credit, I can show my teacher all the work and they know where I maybe made a mistake and can give me partial credit for what I did get correct. And remember, surface area is still area, so our units are still squared. We haven't changed anything. Just because it's a 3D shape doesn't mean we automatically put volume, because we're just looking for the flat surface area of that 3D shape. So 301.44 centimeters squared. So what's the big thing to remember? That when we break this up into our three shapes, we have to use the circumference of a circle to find the length of our rectangle. Our height will always be the height that's labeled in terms of how tall our cylinder is, but that length, when we roll it out, is equal to 2 pi r, or if you remember, pi times diameter, whichever you feel more comfortable using, or maybe it depends on the information you were given. All right, so give a holler if you have any questions. If not, good luck with surface area of a cylinder.